Hello, everyone, and welcome to this fifth session of Multiple Universes. I'm James Barbieri, the Associate Program Director here at the Parry Center, and I will be your host for today. So any problems, technical or not, feel free to just drop me a message in the chat. Before I begin, I'd just like to very briefly go over a couple of rules. I'm sure we all know them, but a refresher is always good. First of all, if you could please mute your microphones during the session, but at the same time, we do encourage you all to turn on your cameras. If you want to ask a question during Q&A or make a contribution, you can use the raise your hand function, which can be found at the bottom of your screen under reactions, or you can physically raise your hand or write your question in the chat and I can read it out for you. And finally, the session is recorded for archival purposes and for you all, and the session should be uploaded to Vimeo in about 3 days. Okay, so today we can start with our session. Today we introduce again Bernard Carr. We all know him, but Bernard is the Emeritus Professor of Mathematics and Astronomy at Queen Mary University in London. His main research area is cosmology and astrophysics, which includes topics such as the early universe, dark matter, black holes, and the Anthropic principle. He was president of the Society for Physical Research between 2000 and 2004, and is currently the president of the Scientific and Medical Network. Today, Bernard will be talking about, is the multiverse in the mind or is the mind in the universe? Welcome, Bernard.
Thank you, James, and I'll share my screen. Incidentally, you referred to physical research. That should have been psychical research, which is one of my other interests. And so let me just put my opening slide up. Great. So can everybody see that? Wonderful. Well, today I'm going to talk about, well, two topics which are close to my heart. The first topic, of course, I addressed in my first lecture, which is the multiverse. And in that context, I was really speaking in my capacity as a cosmologist, which is my professional field. But I'm also going to talk about the question of the role of mind and whether you can have an extension of physics which accommodates mind. And this is something I'm also very passionate about, but I have to say that I'm now veering into the area of philosophy, and I'm not a professional philosopher, and what I say is much more speculative. I mean, you may think the multiverse is speculative, but what I'm going to say in the second part of my talk is even more speculative. And to be honest, I've never linked these two topics together. I give lots of talks about the multiverse to sort of a physics audience. I give lots of talks about the nature of mind and physics to more philosophical audiences, but I've never mixed them together. So I'm really rather pleased to have this the chance to mix them today. This is an image of a brain in a jar, which you may understand the significance of that later, but for the time being, it's just a rather nice picture. So, what is so interesting about the multiverse is that it does involve so many different areas. It involves an interaction with science and philosophy and religion and culture. And indeed, what's been so interesting about these lectures, these talks, is that they've covered all of these different areas. And of course, even this breakdown into four could be divided. I mean, for example, when you talk about science, what do you mean about science? Well, in particular, you can talk about the link with physics or the link with mathematics. And you could go through these other circles and break them down similarly. But the point is that what makes the multiverse so interesting is that it covers and relates so many different areas of activities. But of course, the one thing all these circles have in common is that they are actually all aspects of mind. Whether one's interested in philosophical issues or not, all four of these activities, science, religion, culture, philosophy, involve mind. So you can see why the theme of mind is actually going to link to multiverse. Now, I want to, though, start off by linking it to my first lecture. You remember in the first lecture, I was talking about the multiverse and its role in fine tunings. And I want to show how the different explanations of the fine-tunings relate to some of those different areas. Because if you may recall that the title of my first talk was The Multiverse and the Limits of Science. So I'm going to be continuing to explore the question of what is the nature of science. And well, but first of all, let me just stress that you do get references. The very first references actually to the multiverse arise in philosophy. So this is a quote from William James. Visible nature is all plasticity and indifference. A multiverse, as one may call it, is not a universe. And I think that is the first reference to a multiverse, which came from the philosopher and psychologist William James. There are also references to the multiverse that come from religion. And I'll just give you a few quotes here. I'm not going to explore this in depth, but it really is just to expand on the first diagram. This comes from from the Bhagavata Purana. There are innumerable universes besides this one, and although they are unlimitedly large, they move about like atoms in you. Therefore, you are called unlimited. And here is a quote from this is a Islamic text, Fakir al-Din Arazi. This, and look, the time we're going back way back to the 11th century. In the Matalib, he raises the question of whether the term worlds in a Quranic verse refers to multiple worlds or this single universe in this single universe, or to many other universes beyond the known universe. So again, I'll just read this out. He, the Most High, has the power to create 1,000,000. I can't read the right of it, worlds beyond this world, such that each one of those worlds is bigger and more massive than this world, as well as having the like of this world has of the heavens and the earth and the moons. The arguments of the philosophers, I hope Tim isn't here, the arguments of the philosophers for establishing that worlds is one are weak, flimsy arguments founded upon feeble premises. Well, of course, actually Tim, in his talk, was actually supporting the multiverse, so this was certainly not a criticism of Tim. So again, you have to be careful when you read these old texts, because the question is, what do they actually mean by various terms like universe? But I just want to get across the idea that both in philosophy and religion, the concept of the multiverse has an interesting history. But now I want to get on to the business of the anthropic tunings. And in particular, I want to remind you that there were three explanations I talked about, and those might be described as coming under physics or metaphysics or philosophy and theology. And I'll just remind you, the sort of physical explanation of the fine tunings was that there is a multiverse, lots of different universes in which the constants have different values, such that in some of them you will have the values required for life, and we're necessarily in one of those by a selection effect. There was also the explanation, which I think came from John Wheeler, that in some sense maybe the answer is that you have a Big Bang, and the Big Bang evolves to produce brains and consciousness, and maybe the consciousness in some sense collapses the wave function. The wave function of the universe itself. So in this sense, consciousness actually brings the world into existence, but it can only do so if the constants are such that consciousness can arise. Now, most physicists would regard that as a rather metaphysical explanation, in the sense that it's not really, it depends first of all on the assumption that consciousness collapses the wave function, but the whole tone of the explanation is rather too philosophical for most physicists, even though this explanation came from John Wheeler, who was a famous physicist. But then, of course, there's the theological explanation, which says, well, maybe you can imagine this space of all the constants, possible constants, and God, in creating the universe, merely puts his pin in to select the constants which are required for us to arise. And obviously most cosmologists, most physicists are even more unhappy with invoking God. However, I don't think we have any ground for saying which explanation is actually most likely to be correct. In principle, all three of these arguments might be correct. Obviously, there are a lot of people who want to think that the anthropic fine-tunings testify to the existence of God. Now, I favour the multiverse explanation, but that's not because I reject the existence of God, because in principle, God could create many universes. But this is really a sort of sociological statement. However, you have to bear in mind that actually where these boundaries are between physics and metaphysics and between metaphysics and theology is somewhat subjective. And it all depends on what you might call your boggle threshold. For example, I did mention last time that some physicists are rather skeptical about the multiverse. They think, well, this is philosophy rather than physics because we can't see the other universes. So they would put the multiverse in the metaphysics box, and I suppose they would put the consciousness creates universe explanation maybe in the theology box. And then the original God, I don't know what that is. That must be a sort of it's obviously part of theology. And so that group of physicists would say, well, no, we only want one universe and we don't want God. So, for example, this is a picture that came out of Stephen Hawking's book, The Universe in a Nutshell. So the idea there is that the universe created itself. So you don't need God to create the universe, and you don't need lots of multiverse. There's just one universe and it explains everything. I have to say, Hawking himself ended up being a supporter of the multiverse, but this was nevertheless, it's a nice picture. Obviously, I myself, as I think you'll have gathered, I tend to regard the multiverse as part of physics, but it's a matter of controversy. But the other point I want to make is that the border between I've gone before. I think I had science and physics and metaphysics. Now I'm going from I'm now talking about cosmology in particular, and then I'm calling metacosmology, those questions which are on the borders, if you like, physics and philosophy, or science and physics and metaphysics. And so this is just a rephrasing of the previous diagram. But the point is that the boundary between cosmology and metacosmology is very fuzzy. And actually, this is the point that Tim Maudling was making in his talk. It's very hard to define a clear boundary between physics and metaphysics. And this particularly is true in the context of cosmology. And not only is it fuzzy, this boundary is constantly evolving. And so what was yesterday's cosmology, metacosmology, is today's cosmology. You remember when I gave my overview of the history of cosmology, I stressed how as cosmology advanced, it was always advancing against the skepticism of the more conservative physicists who said this isn't proper science. But gradually, cosmology has become a respectable branch of physics. No one would deny that now. Even though it started off it being philosophy or metacosmology, there's now all the empirical data which confirms that it is a genuine branch of physics. So yesterday's metacosmology is today's cosmology. And likewise, today's metacosmology will be tomorrow's cosmology, I would predict. And something like the multiverse, I would call metacosmology, because we don't yet have the direct empirical evidence for the multiverse. We have indirect arguments for it. It's predicted by some theories of physics, but I would predict that it will eventually become part of cosmology itself once we have the data. And indeed, the whole history of cosmology, I hope I got across in my first talk, has involved a sort of continual transition in what we mean by the domain of science. And it's that expansion of science into the philosophical domains which is causing this arrow to the right. Now, I can just give you a few other examples of metacosmology. It's not only the multiverse. The Boltzmann brane. I don't know how many of you were aware of this image on the front in my first slide. That's a reference to Boltzmann brane, and I don't want to go into this, but the idea is that just through a statistical fluke, if you had a sort of random universe, you might just expect by chance occasionally something like a brain to arise with consciousness, and so this is I'm not very much in favor of Boltzmann's brains, but it's a sort of philosophical issue. Could we just be a Boltzmann's brain? But that's certainly something in the domain of philosophy, but physicists, cosmologists think about it a lot, and this is why I chose that image from my first slide. Another problem, which I'm going to come back to, is the whole question of the passage of time. Time is very much a part of physics, but it's also very much related. The passage of time is very much related to the problem of consciousness, and it's normally thought of a problem to do with philosophy, but actually the passage of time is fascinating precisely because it is on the border of physics and philosophy, and I'll talk about that later on. And I just want to stress this point, that the nature of legitimate science changes, because it's going to play quite an important theme in this talk. And I think I quoted this last time, but I'm going to quote it again. The Steven Weinberg quote. Remember, he was a supporter of the multiverse, and I thought it's worth repeating this. We usually mark advances in the history of science by what we learn about nature. But at certain moments, the most important thing is what we learn about science itself. These discoveries lead to change in how we score our work in what we consider an acceptable theory. And he was saying this because many people say the multiverse is not part of science. And he was arguing, no, actually, with an expanded view of science, it is part of science. And here's a quote from my friend George Stathiou. He was talking about certain ideas in cosmology, such as the multiverse. And such ideas may sound wacky now, just like the Big Bang Theory did 3 generations ago, but then we got evidence and it changed the whole way we think about the universe. I can never see the right of my slide, so I don't know if I've quoted it correctly. I think that's fine, yeah. And so, again, all of this is explaining why that little arrow goes to the right, why the border is always changing between science and philosophy, if you like. Now, I thought I would explore this theme a little bit more by going over the history of physics. And this is my favorite picture. It's called the cosmic uroboros. I'm sure some of you have seen it before. It's the snake which is swallowing its own tail. And the point about this snake is that around the body of the snake are the various structures that exist in the universe. And it's like a ruler. So as you go from the top of the snake to the from the tail, the scale increases by a power of 10 for every minute. If you think of this as a clock, for every minute, the scale goes up by a factor of 10. So you start with the smallest possible scale, which is something like 10 to the minus 30 centimeters. And then as you go round the uroboros, you get to the larger scale, which is something like 10 to the plus 30 centimeters. So it's 60 decades of scale. And you can see the various scales of structure. Down at the bottom, you have people. As you go to the right, you have bigger things like mountains and the planet, Earth, the sun, the solar system, the galaxy and the universe itself. As we go to the left, we have successively smaller things like an ant, an amoeba, a DNA molecule, an atom, a nucleus, and all the various subatomic particles. So in some sense, it summarizes all we know about the physical universe, from the very smallest microscopic scales to the very largest macroscopic scales. And actually, this is a lovely way to represent the history of physics, because the history of physics, well, even the history of science, but let's just say the history of physics can be thought of the expansion of our consciousness to ever larger and smaller scales. And so I'm going to give you a brief, in a few minutes, I'm going to summarize the history of physics to show you what I mean. So it's like a journey, an outward journey to larger scales and an inward journey to smaller scales. So, and I'll be referring here to some of the history of cosmology I talked about in my first talk. So let's take the outward journey, which of course uses telescopes and things like that. We started off with the geocentric view, you remember, which says that the Earth is at the center of the universe. But then we went on to the heliocentric view, which says the sun is the center. And then we looked further and we found that the galaxy, we had the galaxy, and then we had the galactic centric view, which said the galaxy is the universe. And then more recently, of course, in the last century, we ended up with the cosmocentric view, which says that actually there are billions and billions of galaxies, and roughly speaking, 10 billion light years is what you can see. And then, of course, this century we've had the multiverse, which I talked about and we've all been talking about over the last few weeks. And so our vision has our awareness of the universe, our consciousness of the universe, in fact, has expanded to bigger and bigger scales. And the point is, at every stage, the universe has not only got bigger, we've shifted our view of the domain of science. So you remember, for example, the Greeks used to think there was no science associated with things beyond the solar system because that was the divine domain of the divine. Even when we had the heliocentric view, remember the philosopher Leconte said anything outside the solar system can't be part of science because we can't get observations about it. You remember when we had the galactocentric view, how Rutherford, he said he doesn't want anybody talking about the universe in my department. And likewise, when we get to the multiverse, there are people who are going to say the multiverse is not part of science. So all along, you've had this resistance to, expanding science. What about the inward journey? Well, of course, that involved microscopes and particle accelerators. So, of course, we discovered atoms. The idea of atoms, of course, goes back to the Greeks. But even in the 19th century, it's very controversial whether atoms existed. I mean, Dalton used atoms, to understand chemistry, but a lot of people still argued that atoms, there was no evidence for them. It was a philosophical idea. So people like Mach, for example, even in the 19th century, weren't believing in atoms because there was no evidence for them. But then the evidence came. And then, of course, we had the idea that the atom has got a nucleus with an electron going around. There's a picture of a nuclear explosion. And then you got the standard model of physics, which again was just theory until just recently. You remember they discovered the God particle, the Higgs particle, just a few years ago. And so that went from being pure theory to being actually observationally confirmed. So once it's confirmed, it becomes part of science. And then there's still this concept of things like supersymmetry, which they're still trying to find evidence for. And then finally, you've got M theory. And I referred to M theory briefly last time. There's an image for M theory. But as you know, people were saying, well, M theory, it's maths, it's not proper physics because we've got no evidence for it. So to me, the inward path as well as the outward path has the same story to tell. A constant battle to expand the domain of science and to say that this is, it isn't just philosophy, it really is science In fact, the border, as Tim said, the border between science and philosophy is very, very nebulous. Now, I don't want to get too technical, but I wanted to give you say a little bit more about physics here. The other thing physicists have discovered is that there are links, but there are the forces in nature which link the microscopic and the macroscopic domains. For example, the electric force, it holds the electron in orbit around the nucleus, but it also determines the structure of solid objects, like the Earth itself. The weak and the strong forces, they operate inside nuclei, but they also determine the nuclear reactions that go on in the sun, which of course provide the light which keeps us alive. So that's why you have a link, again, from the micro to the macro. The electroweak is the force which unifies the electric and the weak forces. And that obviously is associated with the W and Z particles, so-called, on the left side. But it's also associated with various astrophysical effects. And then what's called the GUT, the grand unified theory. This is the force which is supposed to unify the electric and the weak and the strong. It's associated with various particles you might try and discover in accelerators like the Large Hadron Collider, but it's also associated with the dark matter in galaxies. So you've got this wonderful link. The forces link the micro world to the macro world. And in some sense, the Big Bang is, you might think of as the culmination of that link. And let me explain why the head meets the tail, because why that is actually the Big Bang. The point is, in astronomy, as you look to larger and larger distances, you're looking back in time. So if you look at a galaxy a million light years away, you're looking at it a million years in the past. Well, you remember I told you last time the universe began with a Big Bang 14 billion years ago. So actually, when you're looking to distances of something like 14 billion light years, you're looking back to when the universe was very, 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 very small. So that's why in the Big Bang theory, the very large meets the very small. That's why the head meets the tail. And so this is why I love this diagram. It's a sort of, I'm a physicist, of course, and this to me depicts the triumph of physics. And this is just the, I'm blowing up the midpoint where the head meets the tail, where you got, you've got the domain of, well, quantum theory is what describes the physics of the micro domain, and relativity theory that describes the physics of the macro domain, and they meet in the Big Bang. And actually, I think I used this picture for my first slide of my first talk. And actually, I don't want to get too technical, but I thought I might just add a slide here about these forces, because these forces actually, which the four forces which I've talked about, actually we think of them as separate forces because they have different strengths, but actually we now understand they're all unified as part of a single unified force. And so let me just go over the history of this. I'm not showing any equations, but so I hope this won't get too technical, but I just want to sort of try and get this idea across. The history of physics might be regarded as the history of the unification of the forces. So, for example, Faraday and Maxwell, they showed that the electric and magnetic forces can be amalgamated as part of the electromagnetic force. The weak force can be amalgamated with the electric force as what's called the electroweak force, that figured on my diagram, and that's often associated, for example, with Steven Weinberg, who I quoted just at the beginning of this talk. The strong force, we think in theory that this is going to be linked with the electroweak force in what's called the grand unified theories. Remember, I call that the GUT, the G-U-T. And many people, but there's a picture of Gerhard de Hooft, who's another a famous physicist who works on that. We don't have experimental evidence for that yet, but at least in theory it's been studied for many years. But the ultimate goal is to actually unify gravity, discovered of course by Newton, with these forces. Now that's the real challenge. And the theory which is said to do this is M theory, and I've talked about M theory, it appeared in my uroboros. And there is a picture of Ed Witten. He was the person who in '95 came up with M theory. He has a reputation of being the smartest person on the planet, at least as far as physics is concerned. Now, of course, as you heard, that M theory, it's controversial. We don't have any evidence for it yet. So it's in the domain, if you like, of philosophy rather than physics. But nevertheless, I regard it as, it may be wrong, but I bet you what M theory will turn out to have been, useful, even if it doesn't turn out to be the final theory. But what's interesting about this is that physicists now claim they're on a verge of a theory of everything, in the sense that they now have a unified understanding of all these forces, and which underlies also this beautiful cosmic uroboros. And so that's why one says physics is so triumphant. And in some sense, the cosmic uroboros represents the triumph of physics. But it also poses a dilemma. Because you remember you've got M theory on the left and the multiverse on the right. And there are many people who say M theory is not proper physics because there's no evidence for it. The multiverse is not proper physics. And this is a paper in Nature, but from George Ellis and Joe Silk, where they actually saying attempts to exempt speculative theories of the universe from experimental verification undermine science, argue George Ellis and Joe Silk. And now, I don't share that view, but they're both friends of mine, but I don't share that view, but nevertheless, it is the view of many physicists today, that these things, these ideas, M theory and the multiverse, are speculation, they're not proper science. And yet, you see the great paradox here. The triumph of physics has been the way in which it's explored the cosmic uroboros, going up to ever larger scales and ever smaller scales. At every stage, science has, in some sense, expanded to adapt those discoveries. And yet now, just as we're getting to the top, where we have an understanding of everything, lo and behold, it's being claimed, well, this isn't part of science. This isn't part of physics. And yet, this is the culmination of the whole story. So you can see what a paradox there is there. You're saying that, this is the triumph of physics, and yet right when you get to the top, they're saying it's not physics. So there's clearly something wrong there. Now, then this raises the whole issue of what is science. Now, sorry, I gave this slide last time, so let me not go through this slide. I explained last time that what we mean by science is constantly evolving. So you might think it's experimentation, but that's not true in astronomy. You might think you need to have large samples, but that's not true for the universe. You might say, well, you've got to observe things, but that's not true for black holes or quarks or the multiverse. And maybe you have to falsify. I showed this slide last time, but just to stress again that what you think is science turns out often not to be science, or science has a broader perspective than you thought it had. And this is another picture I showed, which I'm going to show again. The point of the way science works is you have an idea, you make predictions, you test it against the observations, and it either confirms the theory or you modify the theory. But as I said last time, the crucial question is, what is the timescale of each of these steps? Okay. Just because we might have to wait 100 years to confirm M theory, and we might have to wait 100 years to confirm the multiverse, does that really mean it's not science, but philosophy? So the point I'm making is that really the same point that Tim made, that the distinction between science and philosophy, or physics and metaphysics, or cosmology and metacosmology, is really very fuzzy. Now, but this itself has an interesting implication. Let me show you the cosmic uroboros again on the left. Now, I've explained how the history of physics can be thought of as the history of the expansion of our awareness to ever larger and smaller scales. So what I've done here is I've taken, this is a historical diagram on the left, and I've taken what was the range of scales we are aware of, for example, at the 12th century, the 16th century, the 20th century, and indeed at the current time, the 21st century. And you can see that on the macro scale, we've already gone to as far as you can go, essentially. I mean, we've seen to the edge of the visible universe. Now, on the micro scale, we haven't, because we can't get up to the scale associated with M theory, because we can only get to something like, 100,000 TeV or something like that, and 10 to 100 TeV. And it's not clear whether we'll have the experiments later to get further. But at the moment, the point I'm wanting to make is that this is a nice representation of the expansion of our knowledge of the universe. And this gets across various points. First of all, as I've already said, scientific progress involves an expansion of knowledge to ever larger and smaller scales. Secondly, the nature of science changes as it progresses and as it addresses new questions. So people keep saying, this is philosophy, not science. You wait a little bit and it becomes science because you get the data. And so the point is that on both the micro and the macro frontiers have always been on the border of physics and metaphysics. It's just a historical fact that that's always been the case on both the micro frontier on the left and the macro frontier on the right. But now that raises a very interesting question, because you see, the whole point is the cosmic uroboros, our theoretical knowledge, has already encompassed the entire domain of the physical universe, from the very smallest scale of the Planck scale all the way to the scale of the observable universe. So in some sense, the micro frontier of physics and metaphysics has met the macro frontier of physics and metaphysics. And so that raises the obvious question: what happens when you merge these frontiers at the top of uroboros? Is that the end of science, because we've discovered as much as we can about the physical universe? Or is it actually the transformation of science? Is it the start of another paradigm? Well, probably a lot of physicists would say that will be the end of physics. You've got to work out the details. But I'm going to argue, no, it isn't the end of science. It's merely the transformation. It's another expansion of science. You see, let's go back to this cosmic uroboros, which represents the triumph of physics. I mean, I've been trumpeting the triumph of physics because I am a physicist, but now I'm going to give you the other side of the story. Something is missing from this picture, and what is missing is any reference to mind. Okay, it's just a discussion of the physical world. In fact, I'm sure a lot of you are into mindfulness. This is the triumph of mindlessness. And so the question is mind fundamental? I'm sorry, I misphrased this. I should have said, is mind fundamental or incidental to the universe? Now, my original slide said mind is fundamental, not incidental to the universe, but I thought I should give the impression I'm very open-minded, so I made it a question, but I forgot to change the not, so it should read, is mind fundamental or incidental to the universe? I think it's fundamental, but nevertheless, I wanted to keep an open mind about this. And so I represent that by putting a little eye in the middle of the cosmic uroboros. Now, I don't know how many of you saw the theory of everything about Stephen Hawking, and I think I mentioned I was Stephen's PhD student, so I knew the family very well, and it's a lovely movie, and I attended the premiere in Leicester Square in London, and actually I sat next to Stephen and Jane during the movie, and Stephen actually, well, let me just give you this is a little joke, because Stephen, of course, spent his life trying to find the theory of everything. And I watched his reaction, and I imagined the next day the newspaper headlines, though they never actually eventuated, but finds the theory of everything enjoyable. Because he did, he found it enjoyable. But you see, the irony, I expect most of you have seen this movie. The irony of this movie is that actually it wasn't really about the theory of everything at all. It was about Stephen's love affair with his first wife, Jane. But of course, the one thing this theory of everything is not going to explain is love. And indeed, as I said, there's no reference to mind. So from my perspective, this theory of everything is not a theory of everything at all. It's just a theory of particle physics, and one needs an expanded version of science which is going to incorporate, things like mind. Now, there are lots of arguments. So I'm now going to give a discussion of why I think mind is significant. And you'll have heard a lot of these arguments before. This is a famous quote from James Jeans. The universe is more like a great thought than a great machine. I mean, it's a remarkable feature that the universe is comprehensible at all. And when you look at that cosmic uroboros, it's like there's a huge intelligence behind the universe. That's why he says it's more like a thought than a machine. Another interesting aspect comes from another great physicist, Paul Dirac, about the beauty of the universe. Dirac said it's more important to have beauty in one's equations than to have them fit experiment. Well, not many physicists would probably endorse that, but nevertheless, many physicists are motivated by the search for beauty, that the final theory of physics must be beautiful. But of course, beauty is something in the mind. And then I'll show you the same diagram I showed you before. I said how this is it's actually what the history of physics is. It's an expansion of consciousness. It's an expansion of our mind to larger and smaller scales. And actually, the whole history of physics is really a sequence. It's a sequence of paradigms. And these paradigms are basically mental models. And these mental models, deviate more and more from our common sense view of the world. So, so for example, Einstein's special relativity demolishes our common sense view of space and time. Quantum theory demolishes our common sense view of elementary particles as being like billiard balls. And obviously, then you get into ideas of higher dimensions and things like that, which I've talked about briefly and we'll talk about further. So, and of course, M theory in particular is a mental model. There's no physical evidence for it. It's a highly sophisticated mathematical model. But if our view of reality is a mental model, doesn't it seem rather odd to say that mind is incidental to the universe? And so really, this is in a way justifying the first part of my title. You might say the multiverse is in the mind, because obviously the mind has created it. I mean, all our theories of the multiverse come out of the mind. But actually, that's true of all of physics. All of physics is basically a model in the mind. I don't mean it's not true, but I mean what we're calling truth is actually ultimately a mental model which doesn't relate to our direct experience of the world. So in a sense, that's the first part of my title. The multiverse is in the mind. But then, of course, you get down to the fundamental question of consciousness. Now, a lot of physicists don't want to talk about consciousness, but you have to grasp the nettle, because now, when you're talking about is mind fundamental, you're talking about is consciousness fundamental. Now, of course, people have different opinions. Here, for example, is a quote from John Watson, who was a psychologist. The time seems to have come when psychology must discard all references to consciousness, when it need no longer delude itself into thinking that it is making mental states the object of observation. So here was a psychologist saying consciousness is not important. Here's a philosopher, Daniel Dennett. Consciousness appears to be the last bastion of occult properties, epiphenomena and immeasurable subjective states. In short, the one area of mind best left to philosophers who are welcome to it. Let them make fools of themselves trying to corral the quicksilver of phenomenology into a respectable theory. And of course, Dennett is a very eminent philosopher. Though, of course, by no means everyone shares his view. But here's a contrary view. Max Planck, a physicist: I regard consciousness as fundamental. I regard matter as derivative from consciousness. We cannot get behind consciousness. Everything we talk about, everything we regard as existing, postulates consciousness. And here's the philosopher, David Chalmers. I propose that conscious experience be considered a fundamental feature, irreducible to anything more basic. And I have to say, I am in the yes camp. I think it is fundamental, but I'm trying to give both sides the story here. But now let's think back about the anthropic principle, which I talked about in my first lecture. And I said here, the question is, what counts as an observer? So I think this is also a slide I showed. And that's not clear. I mean, the anthropic principle is a selection effect. The universe must allow, in some sense, observers. But what counts as an observer? Is it only a professor of mathematics, or a mouse, or a robot, or a photon? I deliberately was non-committal in my first talk, but I want to tell you now, I'll express my own view. To me, consciousness is crucial. So not all the advocates of the multiverse will accept that, but to me, consciousness really is crucial, I think, to the anthropic principle. I mean, when I write about the anthropic principle, I write about the multiverse, I never mention consciousness. But in this talk I am, because to me, I do think consciousness is the crux of the matter. So this is not a minority view. I mean, well, at least a lot of eminent physicists have taken this view. For example, I'll quote a few here. Wigner: it's not possible to formulate the laws of physics in a fully consistent way without reference to the consciousness of the observer. Noam Chomsky, who of course is a linguist: physics must expand to explain mental experience. John Wheeler, who had this, this picture of the universe creating itself. Mind and universe are complementary. And then Bernard d'Espagnier: the doctrine that the world is made of objects whose existence is independent of human consciousness turns out to be in conflict with quantum mechanics and facts established by experiments. Now, so these are physicists. Well, Chomsky's not, but nevertheless, it's physicists themselves who are saying that consciousness is important. Now, why they're saying this, to a large extent, as I'm sure you realize, is consciousness relevant to physics? That should have been my title, which has come up last rather than first. Of course, it's because of quantum theory. A lot of the physicists there were quantum theorists. And I don't want to go into this in much detail because you will have heard about this from other talks. But basically the idea, I mean, Ruth and Paul, for example, spoke about this. you know the idea that you've got a wave function in quantum mechanics, and possibly the consciousness collapses the wave function. That's not a majority view among physicists, but it's a view which some eminent physicists hold, including Eugene Wigner. So there's that famous picture again, which came from Wheeler. Another physicist is more extreme. Henry Stapp is a famous quantum physicist. He thinks the observer actually selects the way in which the wave function collapses, which goes a bit beyond Eugene Wigner. Indeed, he's applying that to explain certain phenomena in parapsychology and things like that. But that's even less conventional. And then most famous of all, perhaps, is David Bohm, who talked about the implicate order which underlies the explicit order of the physical world. And incidentally, I must mention David's collaborator, Basil Hiley. I don't know if he's in the audience, but he was one of the collaborators, David, who contributed to this a lot, although much less mystically inclined than David. So I like this picture here. It's the Escher picture of the hands drawing themselves. So it's undoubtedly true that quantum theory is interesting because it hints that mind may play a role in physics. That's not something most, physicists working at the coalface sort of think about much, but at least the people who think about the foundations of physics obviously are aware of that fact. And we've, of course, we heard Ruth give a talk about that. But the point I want to make is this: quantum theory cannot explain mind. I mean, it may show mind is relevant, but I think it's to claim that quantum theory explains mind is overstating the case, in my view. And I like this quote from Roger Penrose. "My position on consciousness demands a major revolution of physics. There is something very fundamental missing from current science. Our understanding at this time is not adequate, and we're going to have to move to new regions of science." Okay, so you really need a deeper model of physics, which underlies both quantum theory and the mind. That's my view, at least. And I say that because there's still a lot of those people who are interested in the mind and interested in things like parapsychology often seem to assume that quantum theory is going to explain it all. And I disagree with that. It annoys the physicists because they don't like quantum theory to be associated with weird phenomena. But I also just think it can't be true. They're relevant. If you believe in these phenomena, quantum theory is relevant, but it can't be the full explanation, in my opinion. And so another way let me go back to this diagram. I'm sorry to keep showing it so often, but you can see I'm a bit obsessed with it. The point is that quantum theory describes the physics of the small, and relativity theory describes the physics of the large. And as I've mentioned, the final theory has to somehow marry quantum theory and relativity theory. Quantum theory and relativity theory are both tremendously successful in their own domains, but actually they're incompatible. And that's one of the great problems. I mean, quantum theory and relativity theory contradict each other, but it's all right so long as you apply them in different domains. The final theory has somehow got to marry them up. And so to me, the question is, and that might relate to quantum gravity and things, but to me, the question is, will the marriage of quantum and relativity theory accommodate mind or consciousness? So there's the famous I again. And I have to say, my prejudice is that it will. But furthermore, I would say that if you want a picture of physics which is going to accommodate consciousness, it will be at the level of the final theory. It's no good looking for it at the level of quantum theory or at the level of relativity theory. But we don't have that final theory yet. But the question is, will it have anything to do with mind and consciousness? Most physicists who work on final theories would say no. However, there are people like Roger Penrose thinks consciousness would be fundamental, and I'm aligning with his opinion. So then the question is, in some sense, this is would be the end of the matter-centric view. You remember that as we go, the history of the study of the large scale went from the geocentric to heliocentric to galactocentric to cosmocentric. In some sense, are we coming to the end of the matter-centric view? Of course, in some sense, the whole concept of matter anyway has been superseded when you talk about quantum theory and higher dimensions. But I mean, to me, I think that's the crucial thing. Now, so what I'm saying is that in some sense, in ordinary relativity, space is associated with matter, time is associated with mind, and space and time, of course, they are amalgamated as part of space-time. Matter and mind are linked by observation, and so you've got relativity theory associated with space-time, quantum theory associated with observations. What I'm saying is you want a unification of matter, mind, space, and time. But this is going to need a radical revision of what we mean by these terms. Now, but then I want to get on to, I'm now going to become more controversial. I mean, so far, the longer I speak, the more controversial I'm being. So the less you should be inclined to believe me. But I'll try not to go on too long. To me, the really fundamental question is consciousness generated by the brain? Of course, 99% of scientists will say yes, and certainly 99.9% of neuroscientists probably say yes. I don't think it's so clear. Here are some quotes from, here's Steven Pinker, psychologist. How could consciousness arise from the brain? Beats the heck out of me. I have some prejudices, but no idea of how to begin to look for a defensible argument. Answer, and neither does anybody else. Donald Hoffman, a cognitive scientist, the scientific study of consciousness is in the embarrassing position of having no scientific theory of consciousness. Stuart Kaufman, a biologist, nobody has the faintest idea what consciousness is. I don't have any idea, nor does anybody else, including the philosophers of mind. I'm sorry, people are attacking a lot of philosophers here, so I'm hoping Tim won't be too upset by this. But and then Freeman Dyson, a physicist, the origin of life is a total mystery, and so is the existence of human consciousness. We've no clear idea how the electrical discharges occurring in nerve cells in our brains are connected with our feelings and desires and actions. So one message I want to get across here is that you can't assume that consciousness is generated by the brain, even though that is what most people do assume. And there is a lot of evidence in certain quarters for the evidence for non-local mind. And again, here's some quote. Non-local mind, meaning that our consciousness is not in some sense just locked into our brains. I hope I'm not overdoing the quotes. Here's William Broad. It may be that our deep interconnectedness with each other and with all of nature is the major conclusion that issues forth from the many findings of consciousness research. Now, actually, he's primarily referring to parapsychology. I wasn't sure if I was allowed to talk about parapsychology in this meeting, but apparently I'm allowed to, but I'm not going into much details. But that's, to me, that if you believe in the so-called psychic phenomena, the implication is that mind is non-local in some sense. But it's not just that. You can talk about creativity in general. Here's a quote from Edison, who invented the light bulb, I guess, and many other things. People say I've created things. I've never created anything. I get impressions from the universe at large and work them out. But I'm only a plate on a record or a receiving apparatus. Thoughts are really impressions that we get from the outside. So what he's saying is, and this is talking about sight, he's saying that it doesn't come from inside his head, it comes from outside. And here's a Mahler, the composer. My symphony will be something that the world has never heard before. I tell you, at certain places in the score, a quite uncanny feeling takes possession of me, and I feel as if I had not created this myself. And of course, we're quite used to this idea. Mozart used to have his symphonies just come as though from outside. And here's a quote from the poet. William Yeats, the borders of our minds are ever shifting. Many minds can flow into one another, create or reveal a single mind, a single energy. The borders of our memories are shifting, and our memories are part of one great memory. And so what this suggests, now, as I said, what I'm now proposing is not mainstream physics. But to me, this suggests that there is, in some sense, a universal mind, that our minds are just part of a bigger mind. And this is Emerson, there is one mind common to all individual men, a universal mind. David Bohm again, deep down, the consciousness of mankind is one. This is a virtual certainty, and if we don't see this, it's because we are blinding ourselves to it. There's a nice little book by One Mind, called One Mind by Larry Dossey, which puts all this evidence together in much more detail than I can do in this short talk. But if there's one mind, that suggests the brain is a filter, that the brain doesn't generate consciousness. The brain is a filter of consciousness. Aldous Huxley. Each one of us is potentially mind at large, but insofar as we are animals, our business at all costs is to survive. To make biological survival possible, mind at large has to be funneled through the reducing valve of the brain and the nervous system. So this is a very different view from the mainstream one. It's saying the brain is just a channel for consciousness, and actually the brain is designed in some sense to block information, a lot of information from our consciousness. And that might seem controversial, but oddly enough, it's not such an easy thing to test whether the brain could be a filter, but it's not something which can be rejected out of hand. There are certain phenomena which suggest that when the brain is incapacitated, one's consciousness is expanding. For example, things like near-death experiences, psychedelics, the Savant syndrome, terminal lucidity. People who have Alzheimer's, and then as they approach death, they can think clearly again. So this comes from a book by Mark Gober, which says, to me, this could support the idea that the brain is a filter rather than a generation of consciousness. And this is very much part of my own philosophy as well. Now, if you remember, I showed the pyramid of complexity in my first talk. I showed how as you go from the Big Bang, the history of the cosmos generates ever more complex systems, and finally on a planet Earth you generate human beings with brains and consciousness. And when I talked in the context of in my first lecture, I tried not to be too controversial, so I just kept it like that. I even advocated calling it the complexity principle. But you notice now I put consciousness at the top, because I've argued consciousness is actually pretty crucial to the anthropic tunings. So then the question is, the standard view is that consciousness, the brain produces consciousness. So it's just the culmination of complexity. Consciousness is the culmination of complexity. So how do you reconcile that with the view that, well, maybe consciousness is more fundamental? Well, the way I do it, I say, well, actually, this consciousness underlies everything, but consciousness with a big C. Not our individual consciousness, but consciousness with a big C. And then this is filtered through the brain to produce consciousness with a little c. So the idea is one mind is mind with a big M, conscious with a big C, and then that's filtered through our individual brains to produce consciousness with a little c. Now, again, this is not mainstream physics. It's the minority view among physicists and neuroscientists and philosophers, but nevertheless, this is the view I personally am enamored with. Now, and so really the question now comes, how far can science be extended? Traditionally, we assume that science is associated with the material world. But what I'm arguing is that we have to expand science to accommodate mind. And I'm arguing that I'm going to argue that can be done. Now, I thought I shouldn't talk about spirit because because of the nature of the meeting being about the multiverse, which is primarily something comes out of physics. But I have to say, I'm also interested in the link with spirit, because if you're going to say mind is important, you've got to say spirit is important. And so if you can extend science to cover mind, you have to ask, well, can I expand science to even cover spirit as well? And again, that's my personal view, but I'm appreciating that this is a minority view. Even the physicists who think that science can be expanded to accommodate mind, most of them would not want to accommodate spirit, because, you know, you're getting into God territory. And in this talk, I'm not talking so much about spirit, but I have to let you know that in the back of my mind, I'm interested in that as well. However, I'm not going to go any further in that direction, else I might get into trouble. And so this brings up the whole question of what is science, and I kept telling you what science isn't. You know, that our concept of science keeps getting changed. I would say that science assumes the world is governed by laws which are discernible by observations, and those observations might be either of the inner world, our mental world, our mystical experiences even, or the outer world, and formulated mathematically. I don't know if that really is the most sensible definition, but that's the way I tend to think about it. Because when you ask about can science be extended to accommodate mind and spirit, of course, it all depends on what you mean by science. Now, so to summarize, well, I'm going into the final part of my talk now. Now, if you'll excuse me, I'm going to put the light on because it's got very dark. And I just feel I look a bit like a ghost. So I'm just going to be 5 seconds. Is that okay? I don't know. You might prefer to not see me, but I thought I should just become more visible. Now, so the point is, we need a new paradigm of physics, and it's got to incorporate consciousness. In some sense, it's going to transcend space and time, because we're in a realm of phenomena which transcends space and time in the normal sense. And it's got to incorporate mental phenomena in a radically new way. I mean, I've given you arguments that from physics that mind may be relevant, quantum theory, the Anthropic principle, and all that. But I want a paradigm which incorporates mental phenomena in some radically new way, a sort of grand unified theory of matter and mind. And the key point I'm going to get across is that this must involve higher dimensions. So now, when I talk about this, it can get too technical, so I'm going to apologize because it's not easy to think in terms of higher dimensions, but I just want to try and get across the basic idea. Can I ask, have I got another, can I go on for another, say, 25 minutes or something like that? Because I'm...
Sure.
Sure? Okay, if you're sure. I don't want to...
Yeah, go ahead.
Okay, so now I want to describe what my paradigm is, but bear in mind now this is even more speculative than what I talked about before. As I say, the longer I talk, the more speculative I become. Okay, so let me just first of all remind you that the Newtonian view is that the arena of physical reality is a three-dimensional space and also time. This is not the correct time, obviously, but well, it probably is somewhere, but it's not here. And both space and time are absolute. I'm sure you're all familiar with that idea. But then we know that at the turn of the 20th century, Einstein came along and said, no, the arena of physical reality is four-dimensional space-time. And so different observers have different time and space axes, but they all agree on light rays are at 45 degrees. I'm not going to go into the details of relativity theory. You either know that or you don't. But the key point about this is that time is a fourth dimension, and an individual object like us, our bodies, they follow a world line in space-time. So as you move to the left and the right, you're following this world line. And so so the world became more complicated, it became four-dimensional, but this is the standard physical picture. But then higher dimensions started coming in. In the 1920s, Kaluza and Klein, two people, they suggested that you need a fifth dimension to unify gravity and electromagnetism. The point is, Einstein had given a geometrical interpretation of gravity by curving space-time. These people said, well, let's try and give a geometrical interpretation of electromagnetism. And to do that, they had to invoke a fifth dimension. But it was compactified. It was wrapped up very small on the Planck scale, which is 10 to the minus 33 centimeters. So you don't actually see it. So I tried to represent this in this diagram. It's hard to think in 5 dimensions. At least at this time of night, but basically the way you can do it is you imagine that you've got all your 3 spatial dimensions are compactified, are pushed into one line, and then the compactified dimension, it's like a little circle, okay, and so if you go to a great distance, you can't even see the circle. It just looks like a tube, like a hose. Now, we don't see the extra dimension because it's much smaller than the wavelength of light. So we could never see the extra dimension, but the idea it is there. Now, for about 60 years, people more or less forgot about this because they were sort of, they got distracted by quantum theory and things. But then in the 80s, superstrings came along. And by then, of course, we knew there were other forces besides the electromagnetic force. And they argue that there are actually 6 compactified dimensions. So you've got your 4 dimensions of space and time, but you've got 6 wrapped up dimensions. So the total dimensionality was 10 dimensions. And then there were different versions of superstring theory. But then in 95, Ed Witten came along and he produced M theory, which says, well, we can actually put all these superstring theories together in one theory if we imagine that we've got 11 dimensions. So you now have 7 compactified dimensions. Now, again, this is hard to visualize, so don't try and visualize it. I just want to get across this idea there are more dimensions. So here is the history of physics going from 4 dimensions to 5 dimensions to 10 dimensions to 11 dimensions. So the basic point, physics gives a sequence of paradigms with increasing dimensionality. This is just repeating what I've just said. Now, not all physicists believe this. Some people think it's just mathematics. I mean, well, they certainly believe up to 4 dimensions. But nevertheless, the fact of the matter is, some of the biggest brains on the planet work on this. I mean, who are in physics departments. So it's certainly not a wacky idea. And again, as I said before, it seems completely incompatible with common sense, but that's the price you pay for unification. The great triumph of physics, that it unifies everything, comes at a price, and the price is that it's not so easy to understand. Now, but there's one particular version I like. It's called the Randall-Sundrum picture, and that says, well, let's expand one of these extra dimensions and say it's not wrapped up, but it's extended. So then you have the idea that our 4-dimensional world is a brane, a B-R-A-N-E, and it's in this 5-dimensional bulk. And the extra dimension is the 5th dimension, and that's what defines the bulk. So it's saying that our physical world is a slice of a higher dimensional space. And actually, this is one of the models of the multiverse, which I talked about in my first talk. So can you hold that thought in your mind? Now I want to return to the question of really the relationship between physical space and phenomenal space. And that is, what is the nature of reality? And so I've got a little diagram here that if you were asked what is the nature of reality, this would be the old-fashioned classical view, certainly up till the 20th century. You've got, say you have 2 people with 2 brains, you've got a cat, and the idea is that the light goes into the brain, the visual cortex, and you produce, each of the observers produces a little cat in their own minds. It's in a dotted rather than solid, because it's not the physical cat, it's their mental cat. And so the view of reality would be there exists a three-dimensional space, I'll read this verbatim, in which are localized both the physical objects, the cat, and the sensors through which we observe the objects, the eyes. Each observer has only partial information about this space, because you can't see everything, but there exists a three-dimensional configuration which gives two-dimensional projections concordant with those presented. So we only see like a projection of a three-dimensional world. So reality is a three-dimensional structure which consistently reconciles our perceptions of it. So that might sound a bit of a mouthful, but I mean, I hope it's pretty clear what I'm saying. That's what we mean by saying the world is real. There is a three-dimensional structure which reconciles all our observations of the world, even though we're observing the world from different places. And I can represent this figuratively by saying our perceptions are these little planes, two-dimensional planes, and the reality structure is this three-dimensional cube. It's just a symbol. But actually, of course, we know that that isn't the correct model of reality. We know that relativity theory says that the world is four-dimensional. So relativity theory implies the physical world is four-dimensional, with the objects and observers being represented by world lines and perceptual fields being three-dimensional now because they contain time. So physical reality is a four-dimensional structure which consistently reconciles our perceptions of it. So let me just draw a diagram. I hope this doesn't get too technical, but this is the famous light cone in relativity theory. So you've now got two dimensions of space, so you can envisage it. And light travels at 45 degrees upon light cone. So when you observe something through light, you're always looking back along the past light cone. And so what happens here? Here is the world line of the brain, which we'll say is straight up. The cat, which we're looking at, there's a material cat in some sense, but the cat, as you see, is where it intersects with your past light cone. And so you have a slightly different picture now. You can think of there's your physical cat, but in some sense, the two observers, they correspond to two different dotted cats depending on where it hits their respective light cones. But it's a very different way of looking at perception. The old-fashioned view, the Newtonian view, is a three-dimensional view. The 3D object produces a two-dimensional percept. The four-dimensional view says that in some sense the 4D object produces both the 3D object, which is where it intersects the spatial section, and a 3D percept, which is where it hits the light cone. And I'm going to argue that's a profound difference, which sometimes even relativists don't really understand very well. Now, so what is the nature of perception? I would say that here's the space-time diagram. Here is the world line of the brain. So my brain here is at the top. Here's the light past light cone. I would say my experience of the physical world comes from the nexus of communication of signals within space-time which reach my brain. Now, of course, that might be light rays, but it's not just light rays, it's everything else as well. It's sound waves, it's touch. And furthermore, there's the distortion of your perception that takes place inside your brain. That's also connected with this, because all the neurons inside your brain, all the neural fibers, they're also part of this nexus of connections. So in this way of looking at things, the phenomenal world is just a part of space-time connected to the brain by the causal signaling network, including neuronal processes. And this is in itself is a fairly straightforward, it's just a restatement of relativity theory, but it corresponds to a sort of extended mind. You see, the point about this is the percept is not in the brain, according to this picture. The normal view, which I gave before of the cat, the dotted cat, is that it's just a little map inside your brain. So, sorry, it is not a cat anymore. It seems to be a naked lady, I'm afraid. But anyway, the point is still made that the view that it's inside the brain, I think, no longer makes sense from a four-dimensional perception, because actually object and brain are just two ends of a four-dimensional chain. You have to think of perception as a four-dimensional process. So when you ask what's the relationship between the object and the thing in your brain, I would say it's a four-dimensional process. And that's, I mean, I don't quite know how even the philosophers of perception, philosophers of mind react to this, but it just seems to me it's almost inevitable. Perception is a four-dimensional process, and you can no longer make the straightforward, distinction between objects and image of objects, which you have in old-fashioned Newtonian physics. Now, but that's not the end of the problem, because the other problem is to do with mind. And there's two problems to do with mind. One is to do with the flow of time, and the other is to do with the specious present. And I don't know if I'll have time to get onto the specious present, but let me start off with the flow of time. The point about consciousness is that it involves the passage of time. So if I take my space-time diagram and I think of my brain as like a wire, the world line of my brain is like a wire, you intuitively think that consciousness is like a bead moving up the wire of your brain. That's how you intuitively experience the passage of time. You also think you have a choice. So, for example, you might decide whether to go left or right or carry on in a straight line. So you think at the present moment you can select your future. But the trouble is, none of that makes sense within the ordinary block universe of Einstein, because that simply doesn't describe the flow of time. Because relativity merges space-time, but space-time is frozen. So it doesn't describe the basic phenomena of consciousness. And I might also say, I don't know if Ruth is watching, but this is very relevant to what Ruth talked about and what she's written about. The same issue arises in the collapse of the wave function. There's a link between the collapse of the wave function and and choosing possible futures, or at least perhaps there is a link. And so we know that Einstein's theory is not complete. So the question is, how do you describe the flow of time? Well, I'm going to give you the solution. Well, this is just some famous quotes. Hermann Weyl, the objective world is, it does not happen. Only the gaze of my consciousness crawling upwards along the lifeline of my body does a section of the world come to life as a fleeting image which changes in time. And here is a famous quote from Einstein. When his friend Michel Besso died, he wrote to the family, "Now he has departed from this strange world a little ahead of me." He died just a short time afterwards. "That means nothing. People like us who believe in physics know that the distinction between past, present and future is only a stubbornly persistent illusion." So from the point of view of standard physics, there is no passage of time. But there is a passage of time. That's what consciousness is all about. And I have to say, one of the world's greatest experts on time is Tim. So I don't know if Tim is going to listen into this, but Tim understands these issues much more deeply than me, and I'll be interested in his reaction. But anyway, there is a solution, one possible solution, which came from the philosopher C.D. Broad. And he said, well, one way we can try and describe time is by invoking an extra dimension. And this extra dimension, in some sense, it's like a second time, but it relates to mental time as opposed to physical time. And the idea is that you could imagine that, here's space-time, and you have a number of different possible futures. With respect to your physical time, you select one particular path, but then you have another future to decide, so you select another path. So you can see this as happening in the world is evolving in a five-dimensional space. Now, I don't think this is a very popular idea among philosophers now, but C.D. Broad was a very eminent philosopher. I like this because it does give a way of describing, the passage of time and the selection of futures, it doesn't solve it altogether, but at least it's one way of describing it. And I like it because actually it relates to M theory. Do you remember I talked about the M theory, which says that the world is a brane in a five-dimensional bulk. In what's called brane cosmology, it's a little bit more complicated because the brain moves through the fifth dimension. Well, that's actually, you turn that on its side, it's exactly the same picture. So I try and link brane cosmology to this view of time. That's not a mainstream cosmological view. I mean, not everyone believes in brane cosmology, but it just shows how you can link a physics problem to a philosophical problem. And so, for example, if I were to sort of analyze all these different futures determination, the idea is that the future is open with respect to T2, but fixed in the past is fixed. So, you know, I've just got a little diagram here where you know your possible futures are shown with dotted lines, and then they gradually solidify. Obviously, this is very reminiscent of the many worlds ish, and there is a link, I think, between many worlds and this way of looking at things. And I'd be interested whether Paul Tappenden has any reactions to this way of looking at things. But the point about this is that what it's saying is that to describe consciousness, to describe phenomenal space, you actually need a five-dimensional model where the fifth dimension is actually related to mental time. So this is what I call a psychophysical space. So in this diagram, I hope it's not too complicated, it's 5 dimensions again, but this plane here is the ordinary physical space. But this space here, which involves the mental time, is perceptual space. So you see both of these as being slices of a 5-dimensional psychophysical space. Now, this is not standard physics. It's all incredibly speculative, but this is just the approach I like. I'm trying to demonstrate in principle how you can expand physics to accommodate phenomenal space. And I just wanted to flash up Ruth's slides again. You remember when Ruth gave her talk, she talked about the possibility that maybe a higher dimensional model is what you require to describe well, some of the anomalies of quantum theory. And so that is also a feat. I think I said that you need a theory which underlies both mentality and quantum theory. And I think the same theory, which is describing the passage of time, might give you some conceptual understanding of quantum theory, though I'm sure most quantum theorists wouldn't accept that. But maybe Ruth can talk about that later in the discussion session. So the point I'm making is that you need space and time for mind. This is Descartes, of course. But it's not the usual space and time. I mean, I've already gone beyond ordinary physical space and time by introducing this extra time dimension, if you like, to describe the passage of time. So what I'm going to do in finance, I'm going to say that you need a sort of higher dimensional structure which contains both normal and even anomalous mental phenomena. So I said that we started off with a 3-dimensional reality structure. That was superseded by a 4-dimensional reality structure. And now I'm saying you need a 5-dimensional reality structure. And now I'm saying for the full picture, which is going to describe not just phenomenal space, you're going to need an even higher dimensional structure, which I call the universal structure. And so let me just show you how that works. I mean, first of all, let me say a little bit about memory space. I'm talking about normal memories of the physical world. You see, the normal view is that memories are generated by the brain and derive from the physical world. So the experiences are internal, they're inside the head. But if the cat is inside the head, how can the memory be inside the head? So this gives rise to the other view, which is that the memories of physical events reflect direct access of consciousness to the space-time which contains the events. So the experiences are in some sense external, and they're just the part of the space-time connected to the brain by the nexus of signaling world lines. So it's the same picture I showed before. Here is the brain, and here is this outlook tree with all the nexus of links. The memory, in some sense, is saying that when I see something, I close my eyes and I envisage it and I remember it. What it's saying is that in this way of looking at things, you're merely re-experiencing the past. At least that's the question. Is memory merely a re-experiencing of the past, or is it in the brain? So this comes down to the question is really, do you have a tag or a trace? The trace says that the memory is in the brain, and again, that's what most neuroscientists would believe. The tag says, no, it's not the memory itself which is in the brain, it's just some link to a point in space-time. But that seems to me a natural implication of the picture I've given you so far. But now let's be more exotic. Let's go into other sorts of spaces. For example, let's talk about dreams. So now I'm apparently going well beyond physics, but I have lucid dreams. I'm sure many of you do, and dreams take place in a space. I mean, actually, I often don't know whether I'm dreaming or not because the space is so much like physical space. And I hope I'm awake now, but Price, the philosopher from Oxford, he proposed that physical and dream events exist simply in different space-times. So I'll give the quote here. We inhabit two worlds simultaneously, the world of common experience governed by physical laws and another space quite as real which obeys different laws. Continuous dream life goes on throughout our waking hours and occasionally we may catch a glimpse of it. So it's rather like the stars. We only see them at night, but they're always there. And then Broad, the same Broad who had this high-dimensional model of time, he says, well, maybe we can merge dream space and phenomenal space into a single space of more than 3 dimensions in which sensations of all kinds exist. And, I mean, dream spaces exist. What I mean is the experience of dreams space definitely exists. But I'm just saying, can that be, in some sense, related to an extension of physics? Now I'm going to get into the topic I was rather wary of mentioning, but I'm just going to mention it briefly because I have to be honest, this is part of my motivation for this model. Though I know, as soon as I mention this, it's going to raise hackles in some of the skeptics. But nevertheless, I'm also interested in the fact that many anomalous experiences involve a space. By anomalous, you might read psychic, or transpersonal or mystical or whatever. So, for example, they're so-called threshold experiences. These are experiences that you have when you're on the border of sleeping and waking, often associated with sleep paralysis, where you hear sounds, you feel things, you see things. Of course, one would just say they're illusions, but nevertheless, that is where lots of people have so-called psychic experiences. This is a reference to the book The Terror That Comes in the Night. I won't go into details of that. Apparitions, well, of course, most people will just assume that apparitions are hallucinations, but there are collective cases where more than one person sees the apparitions, and there are. I'm interested in psychical research, as you may know, and I think that there is evidence that ghosts are more than just apparitions. Let me just go. I'm not going to say they're proof of survival. I just want to say they're more than just apparitions. At least they involve some connection between minds. There's a so-called alleged photograph of a ghost. I wouldn't give it too much credence. Out-of-body experiences. Now, I don't know how many of you have had out-of-body experience. I've had out-of-body experiences all my life, and I mean, again, they could just be rejected as being a hallucination. But all I can say is it's in a space. When you're out of your body, it's like being in a physical space. And indeed, although you might claim that it's an illusion, there are cases where people somehow get information of what's going on in other parts of the world, or even seen in other parts of the world. Near-death experiences, I expect a lot of you have heard a lot about these. I won't go into the details of near-death experiences, but they involve spatial things like going through a tunnel. Again, the skeptic will say it's all an illusion, but it involves a space. And then there are mystical experiences, I just cited one book by my friend Paul Marshall. Again, I can't go into a discussion of mystical experiences except to say the so-called extroversive ones involve a space. And so the point I'm making is that if you want to have a model of mind, you need a space which is not the same as physical space, but relates to it and unifies phenomenal space, memory space, dream space, and all these other spaces. So that's the basic message. And then the universal structure, as I call it, I'll just read this out formally. Mental experiences can be accommodated in a higher dimensional reality structure, reconciling our different experiences of the world. It has a hierarchical structure which incorporates physical space as well as non-physical parts, accessed only by mind. And the way I draw this as follows. You remember I had the view that you got the ordinary four-dimensional space-time, the four-dimensional reality structure, which I can still represent by a cube, and there are the perceptual fields. The idea is that you're expanding your perceptual experience, your mental experience, to incorporate non-physical perceptual fields, in other words, to going beyond what I was calling phenomenal space. And then the idea is that that could be connected as part of this higher dimensional reality structure, which I've represented here by a hypercube. I think Ruth used the same symbol. It's the four-dimensional tesseract, the four-dimensional cube. It's just a symbol to represent it. So the idea is, what one is saying is that you need an extended version of reality which links our different minds, because this is why it links to the concept that our minds, into little minds with a little m, are all part of a unified universal mind. Again, this sounds very mystical. It is rather mystical, but nevertheless, that's the sort of picture I'm trying to get across. And so, again, you might think that's exotic, but I naturally identify it with the higher dimensional space of Randall-Sundrum, which you remember I talked about before. You remember I mentioned and said, hold that thought. Well, here it is again. So now, Randall-Sundrum themselves would probably be horrified that I was making this connection, but it seems to be a rather natural way to make the link with mind, because if you think our four-dimensional world is in a higher dimensional space, you've got to ask what else is in that space. And the only thing I'm aware of are my mental experiences. So it doesn't seem to me so bizarre to say that maybe this higher dimensional space is the space which contains mind and these various phenomena I've talked about. Now, I was going to talk about the specious present, but I've already taken 40 minutes. So I think what I will do, because oh dear, I think I should probably...
Go for it.
Sorry?
I said go for it.
Really? If you're sure, okay, I'll do it as quickly as possible. Okay, there's one more missing part which I haven't talked about, and that's the specious present. Now, what is the specious present? It's the shortest interval of time which we can be aware of. It's part of the recent past, elusively given as being a time that intervenes between past and future. Let's just call it the specious present. It goes back to 1882, but most associated with William James. The prototype of all conceived times is the specious present, the short duration of which we are immediately and incessantly sensible. Now, I'm going to argue the specious present is fundamental to understanding consciousness. And let me just give you a little demonstration of this. Conscious time only exists between upper and lower limits. Now here's a little light going around, okay? And because of our passage of time, we see it as moving around. Now let it move around faster. Okay, it moves around faster. But now if I make it go too fast, more than, say, 10 times a second or something, you no longer see it. It actually just becomes a line. And that's because our specious present is about 1/10 of a second. So anything which is shorter than 1/10 of a second, we can't resolve. So in some sense, if it goes around more than 10 times a second, then you basically no longer have the flow of time. You see it as space. But now let's do something else. Let's slow it down. And then now let's slow it down so much that it takes 100 years to go around. Well, I'm not going to do this, but I don't have time. But the point is, time doesn't exist there either. So our experience of time only exists within a narrow range. And in fact, it's probably not 100 years. It's probably much less than that, because it's to do with the memory time scale. And so the question is this, does consciousness only operate on a time scale like that? Well, first of all, the species present can vary. It's normally 1/10 of a second, but it does change in some circumstances. If you're a trapeze artist, for example, you have to decrease the species present because you need to catch the hand of the person. So your time slows down, so they seem to be moving more slowly. This is a decrease in the species present. On the other hand, in other circumstances, if you're a balance artist, you have to increase the species present so that what seems like 15 minutes to the audience is only looking like 1 minute to the balance artists. So it's an increase of the species present. Then more dramatic examples, you have a crisis, you might be in a car accident and you know that time slows down. So that's a more dramatic decrease. You can have an illness. There was a case of someone with a fever who saw this flashing light and by the window, and eventually realized it was the passage of the rising and setting of the sun. But the species present had gone wrong. There are various mystical experiences. This is a famous poem by Rupert Brooke where he was having tea with his lover and time froze. So the species present became very, very essentially zero. And then there's when people have near-death experiences, they may see their whole life instantaneously. So the species present is expanded. So there are circumstances in which the species present changes. And of course, the question is, well, is that just a function of the brain? I mean, because, the species present reflects the brain. It's conceivable that, when the brain changes, the species present changes. However, I do think sometimes the changes in the species present are so dramatic that it's very hard to say it's connected with the brain. And this is why the question of whether consciousness is generated by the brain comes in. Mystical experience, again, I wasn't going to talk about this, but I guess I can talk about mystical experience if I'm going to talk about psychical research. When people have mystical experiences, there's no doubt that their species present changes. And I'm not going to go through the details of this, but it can expand much more dramatically. And this is a quote from Ed Kelly, it's saying there's an interesting similarity between the description of mystical experiences produced through the stages of samadhi and an early anatomist twisting the focus of a microscope. It's as though the meditator is adjusting the focal length of his mind and encountering systematically different worlds depending on the settings achieved. Now, of course, most physicists aren't going to believe in mystical experiences, but nevertheless, if you take them seriously, it seems clear to me that the species present is changing. And it might become arbitrarily small, it might almost go to zero or go to infinity. And I suppose it's because I'm take those experiences seriously that I want to have a model of physics. And I'm only going to say that this is even more speculative than anything I said before, but in my own attempt to link with physics, I associate you remember there are extra dimensions which are compactified, and I associate those extra dimensions with that sort of hierarchy of species present. So, I mean, again, that may be nonsense. That's just the way my model is working, that you've got all your species presents, and I'm associating the species present with a compactified a hierarchy of compactified extra dimensions, because I never really said what these extra dimensions were. I said in this universal structure there are extra dimensions. I'm saying they're being associated with time. And so, but the basic question is this, why do we think that the only experience of the universe, the only level of consciousness in the universe exists with a specious present of 1/10 of a second? Why do we assume that human consciousness is the only form of consciousness there is? Why could there not be consciousness with a specious present much, much shorter than us or much, much longer than us? So, for example, a computer might have a specious second of a nanosecond, and maybe there's some galactic species with a specious present of a million years. And and so, this is going to get very fanciful, but, maybe you've got human species present, maybe that in some sense you've got a global terrestrial species present, maybe a galactic species present, maybe a cosmic species present. And in some sense, I know this sounds very half-baked and mystical, but nevertheless, if you're going to talk about universal mind, you have to have the idea that there is like a hierarchy of levels of consciousness. Besides normal human consciousness. Okay, and I'm going to finish now. To me, I'm just going to say the fundamental question is, why am I me? Okay, and this relates to a discussion I began to have with Paul. Why am I me and not Paul Tappenden? And I'm hoping in the discussion tomorrow we can sort of somehow address that question, maybe in the discussion. I love some of the diagrams Paul showed. This was a famous picture of Alice and all the different bodies. The real problem is, if there's only one mind, if there's a universal mind, how do you explain the fragmentation of mind into lots of little minds? Which not just me and Paul, but the 7 other billion people. That to me is the fundamental question. And I think the reason I mentioned the specious present is because the problem of what is now and the problem of who am I are really related. So these are the three. Say these are 3 people with their identities are associated with the nexus of signaling in space-time. So these are 3 people, if you like. So, but the question is, why am I associated with one of these in particular? And the point is that I'm showing Paul's picture because of his tree, because it reminded me of this picture here, that we're all entangled. And the question is, the separate identity only exists in the lower dimensional space and is only associated with a narrow range of scales. If you have a higher dimensional perspective, which I'm advocating, of course, you can argue that these are all part of this, that they're all linked, as the individual minds are linked as part of the universal mind. So let me just conclude. I'm sorry, I've gone much, much longer than I should have done. The conclusion is that the extended space and time plays a crucial role in linking matter and mind, and indeed in relating, in some sense, experiment and experience, third person, first person perspectives. And this is obviously very, very speculative, even more speculative than anything I said about the multiverse. But in some sense, the purpose of this link was this talk was to link the multiverse with mind. And the idea is the multiverse of higher dimensions, which was just one of the multiverses I talked about, in some sense, to me, is the most interesting one, because that's the one which links mind to matter. So I'm sorry I've gone on so long. I hope you can go on a little bit longer than the 2 hours with questions, but I'll stop at that point.
Great, thank you, Bernard. Well, thank you. This has really been a fantastic session. You really brought everything. Excuse me. Really brought everything together, and yeah, I mean, don't worry about the time. It was the people's request that you went over, so no issues about that. Okay. Now, unfortunately, as we only have 10 minutes, I don't know how much we can open up Q&A, but we do have tomorrow, where you'll be with us. We'll have all the other panelists, so there'll be plenty of room to discuss about that. But in the meantime, I would like to invite in Shantena, the director of the Carr Center and the chair of this event, to see if you've got a few comments or questions for Bernard.
Yes. Hi, Bernard. What a wonderful lecture. Super rich, super we
Super
love,
speculative.
super speculative. We love following you in the speculative space, which is ultimately what's most interesting to us. It's like physics is wonderful, but who are we is the real question. And I'm with you in that final question, who am I? Why am I me? Why am I me and not someone else? Or, which could be rephrased as like how is individual consciousness with a small c, linked to cosmic or universal consciousness or capital C?
Indeed.
Is there some kind of evolution involved? If there is, does it assume the existence of an outside world in which evolution happens? Many questions could come out of it. I'll just throw it at you as.
I mean, obviously, I can't answer that question definitively, but I can only say that, you know, because it comes down to the question of what is the purpose of existence, and I'm not qualified to answer that at all. But I do think that there are different levels of consciousness in the universe. That there's a hierarchy of levels of consciousness with a hierarchy of levels of species present and a hierarchy of cells. And I think, in some sense, that links to the, you know, naively, you might want to say this: the universal mind or consciousness with a big C. You might want to identify that with God if you want to use that sort of language. But the point I want to make is that actually, it's not just a matter in this picture of saying there's us, there's human consciousness with a little c, and God consciousness with a big C. What I'm saying is it's more natural that there's going to be like a hierarchy of gradations as you go, you know, from little c to big C, and that would correspond to going through a hierarchy of levels of consciousness. And in some sense, there is obviously some concept of evolution. Now, then you get into the question of why does big C fragment into little c? I don't really feel comfortable talking in sort of mystical terms, because I realize that will put off the philosophers and the physicists. But nevertheless, in some sense, it seems to me that consciousness fragments. You know, even the evolution of the universe is a process whereby the universe becomes aware of itself. You know, I talked about the cosmic uroboros, about the we as consciousness are getting to understand the universe. So the fragmentation of consciousness seems to be a process whereby the universe comes to understand itself at all the different levels. And the point is that those different levels correspond to different scales in the cosmic uroboros. They correspond to different sort of different species present. And so that's the only way I can answer. But of course, I'm not talking from any knowledge. I'm just speculating that in some sense, the whole of cosmology is telling us that, you know, you've got this pyramid of complexity. Cosmology tells us that you've got this evolution going on a physical level, and to me, that must also be an evolution on a mental level as well, or even a spiritual level, if you want to talk in those terms. It just seems to be natural, and I think you can sort of understand that if you have this sort of expanded view of consciousness. But as I said, it's all incredibly speculative, and I mean, I'm sure I don't think I'll get an easy ride when the philosophers you know, comment on this. But nevertheless, that's just the way my mind is thinking. Sometimes, you know, I go to bed at night and I think, you know, I wake up in the middle of the night, I think this is completely crazy, you know, all these extra dimensions. Other times I wake up and think, yeah, this must be true. I really don't know.
Thank you, Bernard. Fantastic.
Great. Well, thank you, Santina, for coming in. Now, I know we only have 5 minutes, so I can't really open up the audience and then close it right back in. But I would like to invite in someone who has been mentioned in this talk a few times. I was wondering if Paul, I know you're not on the job today, but if you had maybe a few comments after this presentation.
Okay. Okay, yeah, James, all right. I mean, I was holding off in case somebody else wanted to come in to, I mean, you've blown my mind, Bernard. I mean, there's so much stuff in there. But look, ask for a connection with what I was talking about. There's a connection because, well, a connection with a little bit of what you talk about, in as much as what I was arguing was that we needed a sort of, well, a novel interpretation of the mind-body relation in order to make intelligible Everett's idea of splitting, right? And that's, I mentioned in my talk a thought experiment introduced by Hilary Putnam in the 1970s, which has led to a very widespread doctrine in modern philosophy of mind, which is called semantic externalism or mental content externalism. The idea that indeed thoughts aren't in the head, that your brain in the vat can't be thinking about Christmas because it has absolutely no causal connection with Christmas. Okay, so so in a sense, what I was saying, it moves more in the opposite direction. It's more towards the individualism, right? Because Putnam's argument is this twin earth argument, which is supposed to motivate the externalism. What I do in uniting all the little Alice's in one Alice goes in the opposite direction. It undermines that argument. So it sort of says, well, then that thoughts could be in the head after all. But look, I think what is fundamental, I think the most important thing I need to mention in your talk is that David Chalmers, who you mentioned, who you referred to, he's famous for having said that consciousness is the hard problem in philosophy of mind. But there's another problem, and many problems perhaps, but there's another fundamental problem, which is mental content, right? There's a great deal of evidence in psychology that we can have unconscious beliefs, unconscious perceptions, conscious of a little bit of what's going on. And the question of, so I think we do have to make this fundamental distinction between mental content, which is what thoughts are about, what it's a sort of the aboutness of the mind, what the perception of certain things, and consciousness. Why is it a hard problem? Because you can do a hell of a lot of discussion and investigation of the contents, and that's what modern neuroscientists do. They're trying to investigate how mental contents might be encoded in the brain, right? But that has nothing fundamentally to do with consciousness, as you say. So here, what I'm going to say, so very briefly, what I'm just going to say is, here's a way perhaps of reconciling what you're saying with what you were saying with that, which is, could it be the consciousness is what we all share, and consciousness, who knows how far it extends into the natural world? I have no idea. I have no good idea. But mental contents are very much to do with the individual. So why are you and me? Because I've got different thoughts, different memories, different perceptions. We can share the fact that we are conscious. The consciousness is there, we share it, but it's the content. And the content, I would argue, the content is intelligibly determined by what's going on in the brain, but then that's a very big question. So there we are. That's my
Thank you. I was particularly looking forward to your comments, Paul. And I mean, I do appreciate that in many ways what I've described about goes against not only your views on the matter, but that of most other philosophers, because it's not the mainstream view, and so. I mean, I should also say I'm not a professional philosopher, so I don't know really how my ideas relate to sort of other philosophical perspectives. But I guess the key point I'm making is that in this approach, you have to say that minds are not just separate, that they really are, minds are linked in some way. It's this idea of having a non-local mind. And the reason I'm saying that, though, is because I'm invoking phenomena such as, telepathy and clairvoyance and mystical experience, which I appreciate most philosophers and most physicists won't take seriously anyway. But that is sort of why I'm arguing, along with many other people, that you've got this sort of non-local connection. But then, and again, there I'm talking about contents of mind. So I agree with you that it's the contents of the consciousness which is important. I mean, I'm not really addressing the question very deeply of what is consciousness. I'm talking about the contents of consciousness. But then the question is, if you believe that minds are connected in this way as part of, mind with a big M, then you have this real conundrum. Then what does it mean to say that I am me rather than you? And we had the beginning of this discussion after your talk, actually, because you raised the question. You remember, in our discussion, you talked about the other Paul who's 10 to the 100 light years away, and whether you are to be identified with the Paul 10 to the 100 light years away, which of course is a very interesting problem in itself. But what I'm really saying is, to me, that problem is actually less immediate than the problem of why am I not Paul, who is only a few kilometers away, as opposed to 10 to the 100 light years away. So but then I'm not skeptical about the many worlds either. I mean, the many worlds picture, when I drew this picture about different possible futures, which came out of the broad picture, in some ways it's very similar to the many worlds description. And so I don't have a very clear vision of the connection between the many worlds and the picture I'm proposing. I mean, I think there is a connection, because I said that in some sense the same higher dimensional picture that Ruth wants to invoke to describe quantum theory, I'm saying can describe mental experience. So I think there is a link, but I don't understand it very clearly, which is why I was interested in your feedback. I mean, I know you can't give it off the spur of the moment, but maybe in the discussion tomorrow. So
right.
So maybe I should just leave it at that, but I'm hoping we can discuss it more tomorrow, because I'm just fascinated in this whole issue. And I think your diagram, you see, I loved your picture of Alice with all the different Alice bodies. But I also like it when you can turn the picture on its side and you talk about all the different Alice bodies in time, which you also addressed. What is it connects all the different Alices in time? And then I turn it and I then say, well, what is it that connects all the different Alices in space, in the many worlds? So, I mean, I thought there were so many interesting implications of those diagrams you showed, which really intrigued me. So I'm hoping we can talk about that a bit more maybe tomorrow.
Right. Well, maybe that's what we should do, is we're sort of right. But up to you, James. Do you want to sort of finish it now, or shall we?
Yeah, if that's okay. Well, we've got plenty of time tomorrow to discuss about this. And I'm sure the other speakers might want to jump in the discussion as well. I'm really sorry about it, but it was really great, and I'm really looking forward to tomorrow.
But I really do. I really look forward tomorrow to having, especially the feedback from the philosophers like, Tim and Paul, because they have much deeper understanding than me of these issues, and if they say that this is crazy, I mean, I don't mind that at all. I mean, I'm partly, but I'm just interested to see how it relates to, especially the ideas of time. I mean, no, for example, philosophers of time, they don't seem to talk much about specious present, and Broad's views never seem to be talked about anymore. And I don't know whether that's because they've been all rejected for good reason or just because no one's thought about them. So I'd be really appreciate your feedback on that.
Okay, well, let's see where we get tomorrow. Yeah.
Okay, thank you.
Great. Well, yeah, unfortunately, we should really close. I'd just like to thank you so much, Bernard, for your lengthy and dense presentation. You've been receiving so much love and so much fascination in the chat. It's really been fantastic. So thank you so much for that, Bernard. Thank you, Shantina and Paul, for coming in. Yeah, hope to see you all tomorrow, where we'll have this closing discussion with most of the panelists in the past few weeks. We'll be discussing all the various topics that have emerged, and we'll discuss more about this. We will be hearing from you as well. We are sorry if we didn't get the Q&A today, but we'll get the opportunity tomorrow. Yes, so as always, if you have any problems or questions, you can contact us on our website, social media, or email, james@parrycenter.com to contact me, or eleanor@parrycenter.com to contact Eleanor. And we'll see you again soon here at the Parry Center. Bye-bye.